This presentation will explore how the computer stores different data types in its memory. So memory is simply a collection of bytes, and it can be used to store any different type. You have to tell the computer what type is stored there. Otherwise, it has no idea how to interpret those bytes. So a byte or several bytes could be used to represent a character, a string, an integer, a floating point number, and until you tell it, it has no idea what kind of information is stored in that memory. So our data types start with a character, which is the shortest, simplest type, and it can represent a number from 0 to 255 or a single character. And as you can see, it's 1 byte or 8 bits. An int is typically 4 bytes in a 32-bit environment. If you've got a 64-bit computer, it might be bigger, but it's at least 4 bytes. And these represent integer numbers, which are numbers without fractions. A float represents a number which can have a fraction. Now that fraction might be 0, but it can still have a fraction. And we call anything with a fraction a floating point number. The precision is 6 or 7 fractional digits. Hard to translate into base 10 exactly. And normally it occupies 4 bytes. A double is a double precision floating point, and it can represent about 15 fractional digits. So it can represent bigger numbers with more precision than a regular float. Here's a comparison of some of the integer size specifiers. A short is a 2-byte integer. A long is at least a 4-byte integer, and a long is at least an 8-byte integer. For floating point, doubles and long doubles are both 8-byte values. So integral values hold discrete values. They're 1, 2, 3. There's no 1.5 or 2 1/4. It goes from 1 to 2 to 3. Similarly, it could hold characters like A, B, C. There's no such thing as A and 3/4. You go from A to B. And this is what we mean by discrete values. So the examples are the car, which is representing very small numbers as well as characters, an int, a short int, a long int, and a long. If we say short int or long int, it doesn't matter whether we say int there or not. Short and short int are the same. Now, floating point values have the ability to hold a fraction. And the example includes floats, doubles, and long doubles. We can also have const values, which when you declare a variable to be const, you can initialize it, and then the value cannot be changed after that. This is very useful to make sure that you don't accidentally change the value of a constant. So if we say const double pi equals 3.14, this is called initialization because I'm saying it's constant, its data type is double, its name is pi, and there's its value. And that's called initialization. You can only initialize once when you declare a type. Constants are often put in uppercase so that people realize they're constant. That's not a rule, but it's just a way that C programmers have been doing it for many, many years. Now, characters are assigned bit codes, which means that it's not completely arbitrary, but it's almost. And they just say, oh, this bit pattern is going to represent this character. There are several different encoding schemes used. ASCII is the one that was traditionally used on PCs and Unix systems. EBCDIC is the one that's used on IBM computers, and Unicode is taking over. And Unicode tries to represent every character set on the planet. So it knows all the North American languages, it knows all the European languages, it knows all the Asian languages, and it even knows languages you've never seen, like the languages of the Inuit in the far north. It's got all those character sets in there. And it's trying to be one character set that represents every possible character in the world. So that's where we're going. And most computers now have support for Unicode. Floating point numbers are stored in a far more complex format than our integers. Integers are just base 2 numbers. Floating point is stored more like scientific notation. So if we say 3,600, we often represent it as 3.6 times 10 to the third. And that's the way they store floating point numbers. They've got a sign for the number, an exponent, and then a fraction. The fraction is often called the significand, and floating point storage for a float has a sign, several bits for the exponent, and the rest goes into the significand. Here we've got a sign, slightly bigger exponent, and then a lot more bits for the significand. So the difference between a float and a double is that you can represent a bigger exponent, but then much more precision in the fraction. Let's take a look at the ranges that you can represent with some of these types. A car, if it's a number, goes from -128 to +127. If it's representing letters, then it goes from 0 to 255, representing a total of 256 possible letters. Shorts, which are 2 bytes, go from -32,768 up to 32,767. And an int, which if it's a 2-byte int, is the same. 4 bytes goes up to a little over 2 million. Longs are at least 2 million, and a long has that huge value there. So really what you want to remember is that if you're going to use a short, you can only store numbers up to about 32,000. If you're going to use a regular int, you can count up to about 2 million. And if you have to go beyond that, you should be using a long. Now in the floating point numbers, your average float with minimal representation has 6 significant digits, and its exponent goes from -37 to +37. Typical is the same. A double has a minimum of 10 significant digits going from -37 to +37. A more typical double has 15 significant digits going from -307 to +307 for the exponents. So it now represents much bigger numbers with much higher precision. And then a long double is the same as the typical double. Now this is how you declare your variables. We start out here and we're saying the data type of these variables is called a car, and the variables are called digit and initial. We're going to be able to store values in those two variables, digit and initial, and they can be either numbers from -127 up to +127, or +126, 7, or they could be letters. When you've got several on a line, you can separate them by commas. If you've only got one, you just say int n pages and then put your semicolon at the end. We always terminate lines with a semicolon. Here we're just saying something is a float, cash fare, and item price. Now down here we say we get doubles, age equals 0.0. That's initializing it while we're declaring it. So not only is this saying that I'm going to create a variable called age, but it's giving an initial value of 0.0. Notice that I put in 0.0. I didn't put in 0 because 0 by itself would be an int. 0.0 is a floating point number because it's got a fraction. I put a comma and then I put in my second one, and I can say price per kilo equals 1.98. And I can initialize it like that. I don't have to initialize all of them. I could leave some initialized, some uninitialized. It's entirely up to me. Now, there's a certain way you have to name your variables. It's got to start with either a letter or an underscore, and it can contain any combination of letters, digits, or underscores. The total number of characters has to be less than 32, and it cannot be a reserved word. So the reserved words are all the special words in the language. Auto, car, default, else, for, inline, return. And as you go through these are all the language terms that mean things to the language. Like there's int and short, all the variable types and all the keywords that we're going to be using in the language. If you plan to go on and possibly combine your C with C++, you should avoid any of the reserved words in C++ as well. So that's the end of my little discussion about data types, and it gives you a good concept of how the computer interprets the values in its memory and how you tell it what values are stored there.